Okay, we're going to look at solving equations. Today you'll be able to solve equations and solve problems by writing equations. The first thing to look at is the definition for the solution of equation. So when we say solution of equation, we're talking about the answer. And basically it's going to be any value for a variable that makes an equation true. Next is the inverse equations or inverse operations, So an inverse operation is a set of operations that undo each other. An example of this would be addition undoes subtraction and multiplication undoes in one step, and we're going to solve each equation. So for example A, we're going to use PEMDAS, but instead of going forward, we're going to go backwards. So we're going to start subtraction, addition, division, multiplication, exponents, and parentheses. So my first equation is x plus 4 equals negative 12. I'm going to add 4 to both sides. So I'm going to get minus 4, and then I'm going to get x equals negative 16, and that's my solution. For the next equation, I have negative 27 plus 6y equals 3 times y minus 3. So for this, I'm going to distribute my 3 into my parentheses. So we're going to have 3 times y and 3 times negative 3. After I distribute, I get negative 27 plus 6y equals 3y minus 9. I'm going to add 27 to both sides. So I get 6y equals 3y plus 18. I'm going to subtract 3y from both sides. So I'm going to get 3y equals 18. And then I divide both sides by 3. So I get y equals 6. Okay, so this is your turn. And I'm going to ask you to solve the equations. So for A, I have 12b equals 18. So we're going to divide both sides by 12. I get b equals 1.5. And for my next equation, I have 3 times 2x minus 1 minus 2 times 3x plus 4 equals 11x. We're going to distribute the 3 into the first set and then negative 2 into the second set. So I get 6x minus 3 minus 6x minus 8 equals 11x. And then I'm going to just label them. So I have 6x goes with 6x and the negative 3 goes with the negative 8. So when I collect like terms, I just get 11 or negative 11 equals 11x. So then I take the negative 11x equals 11x and I divide both sides by 11. So then x equals negative 1. Let's go ahead and continue. So for example 2, we're going to look at equations with no solutions and identities. So we want to ask ourselves, is the equation always, sometimes, or never true? Remember, identity is where a number equals a number. So like a 5 will equal a 5. So let's look at where it's always true. So in this case, we have 6x plus 5 minus 2x equals 4 plus 4x plus 1. I'm going to collect like terms, and I have 4x plus 5 equals 4x plus 5. I'm going to subtract 4x from both sides, and I get 5 equals 5. So we can say this is true. And then in this case, we say it's an identity because the variables disappear. So a true statement occurs when the left equals the right. All right, let's look at the next one. I have 2x minus 7 equals 2x minus 7 plus 3x equals 4x plus 8 minus 12. So from here, we're going to collect like terms. I have 5x minus 7 equals 4x plus 4. And then I'm going to subtract 5x from both sides. So I get negative 7 equals negative 1x plus 4. Add 4 to both sides. I get negative 3 equals negative 1x. A variable cannot be negative, so you want it to be positive because you're looking for a positive solution, or positive variable solution, not a positive number. Positive variable solution. So we divide both sides by negative 1. So I get x equals 3. So for this one, you're saying that you have one solution where the variables never disappear. And then in this last example for never, we're going to say 11 equals 3x minus 11, or minus 7 equals 6x plus 5 minus 3. I collect like terms. 3x plus 4 is what I get on the left. And then 6x minus 3 equals 3x minus 5 is what I get on the right. I subtract 4 from both sides. So I gathered like terms. 3x plus 4 equals 3x minus 5. I subtract 4 from both sides. I'm left with 3x equals 3x minus 9. I want to get rid of the variables, so I subtract 3x from both sides, or I want to gather like terms. And so I get 0 equals negative 9. So this is a case where the left doesn't equal the right. So no solution is our answer. And the variables disappear, so we're left with a false statement. All right, so it said, is the equation always, sometimes, or never true? This is your turn, and we're going to work this out together. For A, I have 7x plus 6 minus 4 equals 12x minus 3x minus 8. So I collect like terms. On the left, I get 3x plus 6, and on the right, I get 3x plus 4. I subtract 3x from both sides. I get 6 cannot equal 4. So this one is false. Example, we're going to distribute. I have 2x plus 3 times x plus 4 equals 2 times 2x minus 6 plus x. So right here, we're going to distribute. So I have 2x plus 3x minus 12 equals 4x minus 12 plus x. And then I have 5x. Collect like terms, so I have 5x minus 12 equals 5x minus 12. I'm going to subtract 5x from both sides, and I get negative 12 equals negative 12. So this statement is true.